In this session, we're going to see how to factor binomials that involve cubes. In considering this, we're going to look at factoring a sum of cubes and factoring a difference of cubes. Now, a sum of cubes has the form x cubed plus y cubed. And it's called a sum of cubes because the plus means a sum, and the exponents are 3. The formula for factoring a sum of cubes is going to be, in this case, x plus y times the quantity of x squared minus xy. I'm taking my time here so I can color code this, plus y squared. A difference of cubes is very similar. We again have two terms, but they're separated by a minus sign, x cubed minus y cubed. And the formula for factoring a difference of cubes looks a lot like that for a sum of cubes. We have a small set of parentheses and then a longer set of parentheses. And we start out with x minus y in the small parentheses, and then x squared plus xy, again taking time to color code this, plus y squared. This can be generalized using an acronym SOAP. And I'll show you what I mean by that. Let's consider the sum of cubes. For the sum of cubes, x cubed plus y cubed, in the first set of parentheses, the sign matches. It's a plus. And so this is the same sign. For the second set of parentheses, the sign between x plus y switches. This is the opposite sign. And finally at the end, the plus y squared is always positive. And so that gives the acronym S-O-A-P, SOAP. So let's look at the difference of cubes. X cubed minus y cubed factors into, in the first set of parentheses, x minus y. Notice that's the same sign. And then for the larger set of parentheses, we have x squared plus xy. Well, that's an opposite sign. And then finally the plus y squared. That's always going to be positive. And so we have the same sign, the opposite sign, and then the last term is always positive. Let's verify the formula for factoring a sum of cubes. So I've rewritten the formula x plus y times the quantity of x squared minus xy plus y squared. And we're going to verify the formula by simply multiplying it out. And we're going to break out the rainbows. X times x squared is x cubed. Distributing further, we have x times negative xy is negative x squared y. And x times y squared is plus xy squared. Moving on to the y, we have y times x squared, and I'm going to line up my like terms. So this is going to be a positive x squared y. Y times negative xy is negative xy squared. And finally y times y squared is a positive y cubed. I can see that some of the like terms subtract out, leaving me with x cubed plus y cubed, thereby verifying that this is the correct factorization of the sum of cubes. I leave it to you to verify the difference of cubes. Let's get started with our first example. We have here 8y cubed minus 27. And I notice that 8 is a perfect cube, 27 is a perfect cube, and of course y cubed is. And so here we have a difference of cubes. A lot of times it's useful to write this in a format that makes very obvious that this is a difference of cubes. And so I'm going to use some parentheses here and color code as I did in the previous screen. And here we have a difference. So the first term, 8y cubed, is the cube of something, and if we can figure out what it's the cube of, it makes this process a lot easier. And I notice it's the cube of 2y. So this is 2y cubed. 27 is also the cube of something, and it's pretty clear to see that this is the cube of 3. So using the formula that we just saw, we're going to have a smaller set of parentheses and a longer set of parentheses. In the first set of parentheses, we're going to use the same sign that was in the initial expression, and so 2y minus 3. Then we're going to use the pattern here, 2y squared plus 2y times 3 plus 3 squared. Notice we're using SOAP. In the first set of parentheses, we have the same sign. From that to the next parentheses, we have the opposite sign. Finally, the last term is always positive. Simplifying inside the second set of parentheses gives us our answer. We have 2y minus 3 for the first set, and then 2y, the quantity squared, is 4y squared. Keep on writing, plus 6y plus 9. And this is the factorization of this difference of cubes. Next we have 2x cubed plus 54, and I notice that neither one of these terms is a perfect cube. However, I notice there's a greatest common factor of 2 in both terms. So I'm going to factor that out, 2, and I end up with the quantity of x cubed plus 27. And I notice that x cubed plus 27 is a sum of cubes. I'd like you to pause the video, take a moment, and factor this using the pattern we saw earlier. Okay, I'm going to rewrite this. 2 times the quantity of, in blue I have x, that's cubed. In green I have 3, and that's cubed. So I've rewritten the x cubed plus 27 as x cubed plus 3 cubed, making it obvious that we have a sum of cubes. Now that sum of cubes is going to factor. We're going to use a small set of parentheses, then a longer set of parentheses. The factor of 2 that we factored out is going to come along for the ride, kind of like a nagging baby brother you can't get rid of. And so inside the first set of parentheses, we're essentially going to drop the cubes and simply write down x plus 3, keeping the same sign as what was in that binomial. And then for the second set of parentheses, we're going to take that x and square it right down to negative. That's an opposite sign. Multiply the x times 3. I'm going to put the 3 first, just because of convention. And then finally, the last term is always positive, plus 9. At this point, we have the final answer. But we can examine this just a little bit. For the first set of parentheses, as I said, we just dropped the cubes, and when we had x cubed plus 3 cubed, we're writing down x plus 3. That's the same sign as we've talked about before. At this point, we can completely forget about where we came from. Well, kind of. And focus on the x is going to get squared. The 3 is going to get squared. That's going to give us the x squared and the 9 in the big set of parentheses. And remember, that 9 is always positive. If we multiply the x and the 3 together, that gives us the 3x. Keeping in mind the SOAP part, we have a negative sign in front of that 3x. I go over it this way so that you don't try to memorize that pattern. If you can rather think about how to get the second set of parentheses from the first, and how to get that first set of parentheses from the original sum of cubes, makes this process a lot easier. I'm going to clean this up just a bit, and here I have the final answer. For our next example, we have x to the 9th minus 8/27 y to the 6th. And at first, we see the fraction, we see a 9th, and we might want to turn tail and run, but if we can express this as 2 cubes, then we might see how to flesh out this pattern. Notice that this is a minus in between, and so this is going to be a difference, hopefully, of cubes. Let's see if we can do that. If x to the 9th is a cube, then what's it the cube of? It's the cube of x cubed, because remember, when we take a power to a power, we multiply the exponents. If 8 over 27 times y to the 6th is a perfect cube, what is it the cube of? As it turns out, 2/3 y squared. Now I'm going to factor this in kind of an abstract way. In fact, I'm just going to go for the colors. So let me rewrite this in a slightly different way. So I've rewritten this as essentially blue cubed minus green cubed. And using SOAP, I'm going to write a smaller set of parentheses and a larger set of parentheses. For the first set of parentheses, we're going to drop the cubes. And I have blue minus green. For the second set of parentheses, we're going to have blue squared. Now it's the opposite sign, so plus blue times green. And then the last term is always positive, so plus green squared. This is how we use a formula in math. It doesn't matter what it is that's in the cubes. This is the pattern every single time. Now all that's left is for me to fill in the blue and the green with the appropriate thing. Since what's in the blue is x cubed, I'm going to write x cubed everywhere I have a blue box. And since what's in the green is 2/3 y squared, I'm going to write that in the green boxes. For proper form, we should put the x cubed that's squared as parentheses x cubed and the squared outside the parentheses. Likewise with the 2/3 y squared squared, it should be the quantity that's squared. Now I can clean all of this up. In the first set of parentheses I have x cubed minus 2/3 y squared. And in the second set of parentheses, this x cubed squared is going to become x to the 6th because we multiply exponents. In the middle term, we'll end up with plus 2/3 x cubed y squared, putting these in alphabetical order. And finally, applying the squared to the factors in the last term, we have 4/9 y to the 4th, again multiplying exponents as appropriate. And here we have factored this difference of cubes without breaking a sweat. Next we have 125x cubed minus 4x minus 1, the quantity cubed. See if you can factor this like we did the previous one. So I've rewritten this, color coding the terms, and I have 5x, the quantity cubed, minus 4x minus 1, the quantity cubed. In keeping with what we've done before, I'm going to write a smaller set of parentheses and a bigger set of parentheses, hopefully leaving enough room for the binomial. Okay, drop the cubes, and for the first factor, in the first set of parentheses that is, I have 5x minus the quantity of 4x minus 1. Notice I'm using parentheses because I have a minus in front of a binomial. In the second set of parentheses, we're going to take the 5x and cube it. We're going to use the opposite sign, so I'm going to write a plus 5x times 4x minus 1. These I'm getting directly from the first set of parentheses. And then finally the last term is always positive. We're going to take that 4x minus 1 and square it. Now we can see that we have some cleaning up to do, simplifying inside the second set of parentheses. First I'll rewrite the first set, 5x minus 4x plus 1, distributing that negative. And in the second set of parentheses, well, I just noticed I made a mistake. Hopefully you caught it. in that bigger set of parentheses I wrote 5x cubed, and that should be a 5x squared. My bad. Alright, simplifying that, I get 25x squared plus 20x squared minus 5x, that's from distributing the 5x, and then squaring this binomial 4x minus 1, I think I'm going to have to spill over to the next line, is 16x squared minus 8x plus 1. Now it looks like I have some like terms that I can collect inside of each set of parentheses. 5x minus 4x, well, that's simply going to be x plus 1. And in the second set of parentheses, we've got 25x squared plus 20x squared, that would be 45x squared, plus 16x squared, that's going to give us 61x squared, minus 5x minus 8x gives negative 13x, finally plus 1 gives us this factored form of this difference of cubes. This brings us to our final example, x to the 6th minus y to the 6th. We're going to end up factoring this in two different ways. I can express this as a difference of cubes by considering x squared cubed minus y squared cubed. I could also, though, think of this as a difference of squares by considering x cubed squared minus y cubed squared. So we're going to factor this, like I said, in two different ways. First, let's look at this as a difference of cubes. For the difference of cubes, we're first going to drop the cubes, write down what we have inside the parentheses here. And so in the small set of parentheses, well, let me write the bigger set here. In the small set of parentheses, we're going to write down x squared minus y squared. And then in the bigger set of parentheses, we're going to write down x squared squared. The opposite sign means plus, in this case. X squared y squared. And then the last term is always positive. Plus y squared squared. Now I can simplify in the second set of parentheses, but I can further factor in the first set of parentheses. I'm going to do both those things in this next step. X squared minus y squared factors into x plus y times x minus y. And then in the bigger set of parentheses, x squared squared, we'll multiply exponents, gives us x to the 4th, plus x squared y squared, plus y to the 4th. That would be a sufficient answer as far as I'm concerned. However, if you looked at this problem off the bat and noticed it was a difference of squares, then you would have factored it thus. A difference of squares factors into two products, one with a plus and one with a minus, so let me write that in. And here I'd have x cubed plus y cubed and x cubed minus y cubed. And notice that each of these factors is now a binomial involving cubes. So factoring each of these in turn gives us basically the formulas that we started out with. This first factor is going to factor into a smaller set of parentheses and a bigger set of parentheses. The second factor, likewise. So let's take these one by one. X cubed plus y cubed is going to factor into x plus y, because for the first set of parentheses, we essentially drop the cubes. And then, focusing on this x plus y, we're going to have x squared minus xy plus y squared, using that SOAP acronym that we saw earlier. And then factoring that x cubed minus y cubed, we get x minus y, because for the first set of parentheses, we essentially drop the cubes. And then focusing on this x minus y, the x gets squared, the y gets squared in the end. That one's always positive, so let me put a plus there. And then the x minus y, we're going to use the opposite sign. And so we're going to put a plus xy multiplying those two factors together. That's how we're going to use SOAP. Now we can rearrange the terms here, put binomials in front, x plus y times x minus y, and then we've got the two larger set of parentheses that I'm going to write one by one. We have x squared minus xy plus y squared, and then x squared plus xy plus y squared. I notice that there's not a greatest common factor that I can pull out, and so I'm pretty well stuck at this point. And here I would have an alternative answer. And on a test, I would have to take either one of these. So I'll circle it as well. But let's compare the two that we came up with. First we had x plus y times x minus y. That shows up in the second answer as well, x plus y times x minus y. The remaining factor in the first answer must be equivalent to the two remaining factors in the second answer. I wouldn't require that you factor this x to the fourth plus x squared y squared plus y to the fourth. We don't have a technique for doing that. This just underscores that sometimes things can be equivalent to each other even if they don't look like it. But as I said, I would accept either of these two expressions as your final answer. Okay, so as I was reviewing this, I realized that I had some bad form up here, so I'm going to bring this back up here. When I originally factored this using the difference of cubes, for the y squared squared in the second set of parentheses, that 2 right there, the squared, looks like it's outside of the black parentheses. Bad teacher. Smack myself on the hand there. Let me clean this up and write it how it's supposed to look. And if you're wondering why I left it, well, frankly, I didn't want to have to do the whole thing again. So this is how it ought to look, with x squared squared inside the parentheses, x squared y squared inside the parentheses, and the y squared squared inside the parentheses. The way I had written it before, let me go back to it, made it look like the squared was outside, which would indicate I'd have to square the whole trinomial, which is not what I meant. So let's let that be a lesson to be careful where we write stuff.